All right, number 42. If you know the positions of a moving object at 2 points along its path, and you also know the time it took for the object to get from one point to the other, can you determine the particle's instantaneous velocity and how about its average velocity? Both of these, both highlighted or underlined in red and blue, have the same formula. So it's kind of nice. We'll just do the average velocity. We can either call it the instantaneous or average, but for this we'll just do V average, and that is equivalent to Y final minus Y initial, and that's going to be over time. Or I'm sorry, I should probably use the X coordinate here. That's going to be over, let's do this, X final minus X initial, or position over time. So we can use this for velocity average or average velocity and also instantaneous velocity. So I'll also put a little equal sign, which is also equal, and we'll just do velocity inst or ins for instantaneous velocity. And here's how this works. So on the graph itself, we're going to choose 2 points on the graph, and we're going to follow this formula. So, we're going to choose 2 points for the average velocity, and they have to be on the graph for average velocity. So let's cover this. V average, I'll circle here in blue. Velocity average, we have to have 2 points on the actual line that the movement is making. So let's go over that first. Y final is going to be here. We have it in red, final, and it looks like Y final is going to be 0.4 meters, and Y initial is at 0.5 meters. Okay, and that is going to be over our time of X final, which looks like it's 1.2 seconds, minus a 0.8 seconds. So if we do that math correctly, I'll just use a calculator to zoom through this. We have 0.4 minus 0.5. We get a negative 0.1. Now we do 1.2 minus 0.8, and we have a 0.4. So we have a negative, here we go, negative 0.1 divided by 0.4, and we get a solid negative 0.25 meters per second. Because when we divide the second and the meter and the second combine, so we get negative 0.25 meters per second. That's the average velocity between these 2 points. Now, if we take instantaneous velocity, I'm going to chuck this ruler in here, and let's do the instantaneous velocity of our initial point. Watch what I have to do here. So the instantaneous velocity at this point, we have to make a perfect tangential line. This is called a tangential line, what we're doing here. I'm going to make that in red so we can really see it. So I'm just going to make that line like that. Now, I can choose any 2 points on that tangential line, okay? So we have 1 point, and we follow the same formula here, and I'll do this one in red. So I'll do it over here. Ooh, let's see here. There we are. So we have our, this might get a little messy, but we have our initial at the same location, at this dot. Let's do our final over here, okay? And so we have our final for our instantaneous right here. Okay, so our final, we have 0.5 for Y, and that's in meters, minus 0.5. You can already tell what the answer is going to be here. And then for our seconds, we have 1.6 seconds minus, and we have 0.8 seconds. Okay, so 1.6 minus 0.8 will actually be 0.8, and 0.5 minus 0.5 will be 0. So we have 0 over 0.8 seconds, 0 meters over 0.8 seconds. And as you know, and I can prove it on the calculator, 0 divided by anything is going to be 0. So our instantaneous velocity is actually going to be 0 meters per second. And that's our V instantaneous. All right, thank you.